Alright, this is lesson 20. We're going to solve quadratics by graphing. So today we're going to be solving quadratics by graphing. Quadratic equations are a part of the set of equations that are U-shaped. So in math there's all sorts of equations. There's linear equations, right? Quadratic equations, exponential equations, cubic equations. So you need to be able to recognize them. We graph all sorts of different kinds of equations so that we could understand their properties better. Okay? So our goal today is to graph the equations, the quadratic equations, and we're going to find solutions by graphing. Okay? So today's going to be kind of intense. Okay? It's going to be a lot, so I need you to focus while I'm showing you how to do the work. Here are the steps for today. If you're on the video, you should pause it here. I'm going to move on to numbers 1 and 2. Okay, number 1. Okay, graph and solve. So I'm going to be graphing number 1. It says x squared minus 8x plus 15. The first thing I want to make sure is that it's in standard form, meaning that the x squared term is first, then the x to the first power, and then the 15, or then the constant power. Okay. So in this case, it is in order. So a is equal to 1, b is equal to negative 8, c is equal to 15. So, once we have a, b, and c, we're going to take negative b over 2a. And we need to find the vertex. So, our graphs will look like a U. It either look like this, or it's going to look like this. We don't know what it looks like yet. But the vertex is always the point that's at the end. So, in this case, it would be what that point is. We don't know what it is. That's not exactly what it is. Alright, so we're going to plug it in, negative b over 2a. We got negative 8 over 2 times a, 2 times 1. Okay, negative 8 is positive 8 over 2 times 1 is 2. Negative 8 divided by 2 is 4. Okay, this 4 only gives us the first part of our coordinate. That means our vertex will be at 4 something. We don't know what that is yet, so we're going to figure that out right now. Okay, so we're going to plug 4 back into our original equation right up here. So we're going to ask ourselves 4 squared is 16. Then we got negative 8 times 4 is negative 32. And then we got 15, then we have 15 at the end. And we're going to combine this. We got negative 16 minus 32 is 16 minus 32 is negative 16. Negative 16 plus 15 is negative 1. Okay? So that is where our vertex is for negative 1. So that is where it's going to point to. Then we're going to pick 2 bigger numbers than 4 and 2 smaller numbers than 4 to put in our table, 5 and 6. And we'll pick 2 smaller numbers, 3 and 2. And we're going to start plugging all of these numbers into our original problem up at the top, okay? Okay, so at the very top, let's put in 2. If you're looking at the very top, 2 squared is 4. 2 times negative 8 is negative 16 plus 15. 4 minus 16 is negative 12. Negative 12 plus 15 is positive 3. Put a 3 here. And we do that again for the next one. 3. We got a 3 in here, so we're going to put 3. 3 squared is 9. Negative 8 times 3 is negative 24 plus 15. 9 minus 24 is negative 15. Negative 15 plus 15 is 0. Okay, next one is 5. Okay. What's that? Okay, so 5 squared is 25. Negative 8 times 5 is negative 40. And we're going to work it out. 25 minus 40 is negative 15. Negative 15 plus 15 is 0. Okay? Then we have 6. Last one, 6. 6 squared is 36. Negative 8 times 6 is negative 48. Plus 15 I know that's 36 minus 48 is negative 12. Negative 12 plus 15 is 3. Okay? So now I have all my ordered pairs here. I know that 4, negative 1 is my vertex. I already plotted that, so this is my vertex right here. Then I have 2, 3, 3, 0, 5, 0, and so forth. Oh, that's supposed to be an arrow at the top. Okay, and that's it. It opens up, and this is our vertex. So that's how you graph it. Now we need to look at, from this graph, I could derive a solution. So I have solutions occur whenever this graph crosses the x-axis. So this is our x-axis right here. All right, so where does it cross? It crosses at 2 points right here. What is x equal to at these 2 points? Well, x is equal to 3, and x is equal to 5. Okay? Another place to look at it is look at the table. Where is y equal to 0 in the table? Looking at the y values. Okay, where is y equal to 0? It's equal to 0 here and here. So what's the x value? 3 and 5, the same. Okay? So the goal of today is to graph this graph, the quadratic graph, and to find any solutions that are there. Okay? That's how you do number 1. Let me do number 2. I'm going to go a little more quickly, but we're going to do number 2. Same steps. I'm going to graph it and identify any solutions. So number 2. Number 2, I have a, b, and c. It's in order negative x squared minus 6x minus 7. Okay? So I know a is equal to negative 1, b is equal to negative 6, and c is equal to negative 7. Okay? Then I'm going to start with negative b over 2a. Plugging in my values, I know that b is equal to negative 6, so this could be negative 6 over 2 times a, which is 2 times negative 1. Negative 6 is 6 over negative 2. Negative 6 divided by 2 is negative 3. That is where our vertex is going to be, so I'm going to write an xy table. I'm going to put negative 3 in. I'm going to pick 2 bigger numbers, which is negative 2 and negative 1. 2 smaller numbers, negative 4 and negative 5. Okay, starting with my vertex, negative 3, I'm going to plug it into my original formula. Look up here carefully, please. Negative 3 squared is 9, but we have this negative sign I'm going to bring up. Okay, so we have really 9 and then a negative sign there. So then we have negative 3 times negative 6 is positive 18 minus 7. I know if I have negative 9 plus 18 is positive 9. 9 minus 7 is 2. Okay, that's where my vertex is. So I'm going to plot that point while I'm at it. Next one, I'm going to go to negative 5. I'm going to plug negative 5 in here to the original problem at the top. So negative 5 squared is 25, but I have this negative sign I have to bring up, so it's negative 25. Negative 6 times 5 is positive 30 minus 7. Negative 25 plus 30 is 5. 5 minus 7 is negative 2. So I'm going to plot that point here. Okay, and then we have negative 4. Negative 4 squared is 16. We have a negative sign here. Negative 6 times negative 4 is positive 24. Positive 24 minus 7. So we have negative 16 plus 24 is going to be positive 8. Is that right? Yeah, positive 8. 8 minus 7 is 1. Okay. Now from my first problem, I know that this graph looks symmetrical, like our face looks symmetrical. If I were to draw a line down your face or anyone's face, you have an eyeball on one side, you must have an eyeball on the other side, right? If you have an ear on this side of your head, you should have an ear on the other side of your head. Did you notice that these numbers here on the first problem, they are symmetrical around the vertex? You see how 0 is copied to here and 3 is copied to here? So we could assume that this one I could copy right here, and I could assume this negative 2 I could copy here. I gotta graph my points. Oop. Okay, just graphed it. It's opening down. So now I'm going to look at where it crosses the x-axis. Unfortunately, on my table, there isn't any place where y is equal to 0, so I can't assume what it's going to be equal to. But I could look at my graph, and I'm noticing, hey, look, it crosses at these 2 points, so there are 2 solutions. They're not exactly at these halfway points, so I'm going to use about. I'm going to estimate. In a couple days, we'll know what these are exactly, but x, in this case, is about -4 1/2. It's not equal to, but it's about -4 1/2. So I'm using these squiggly equal signs. Then x is equal to -1 1/2. Okay, not totally equal to, but about. So I'm going to use these squiggly lines. -1 1/2. Okay, because I'm estimating. All right, I know this is a lot of work. It's a little overwhelming. But this is one concept. We're looking at graphing and looking at solutions. So let's have ones pick one of these 2 problems, okay, before we move on. Ones are talking about one problem. Explain, how did I graph it? Talk about how I got A, B, and C, -b over 2a, plugged it in, made a table, and graphed it. That's what ones are doing. When ones are done, then 2s are going to talk about how did I pick my solutions? Okay, how did I know these are solutions? And 2's also explain why I use the about sign, which is the squiggly equal sign. Okay, ready, set. Okay, so continue on number 3. Okay, number 3 we got 2x squared plus 4x, okay? 2x squared plus 4x. First thing we want to do is make sure it's in the standard form. So looking, is the x squared term first? Yes, it's first, and it's x to the first term. Is there a c in this case? No. What can I do to make sure that there is a c? What? Put a 1? Why would I add a 1? That would change the whole thing. Add a 0, right? What happens if I add 0? Nothing. It's a place marker, right? So a is equal to 2, b is equal to 4, c is equal to 0. Right? Next thing we're going to do is figure out -b over 2a. I'm going to do this on the side. So we're going to put -2, or -b, so we have a negative sign. Our b is 4. It's not a -4, just regular 4, over 2 times 2. So we have -4 over 4, which is equal to -1. Alright, that's going to represent our vertex, so we're going to make an xy table. And we're going to put in -1 as our first point. Okay? Okay, so looking over here, -1. What are 2 bigger numbers than -1? 0 and 1. Okay. What are 2 smaller numbers than -1? -2 and -3. Good. Let's start with -1. Let's put -1 into our equation. What's -1 squared? It's 1. 1 times our coefficient of 2 is? 2. Good. Okay, so I'm going to put 2 up here. And we don't need this place marker of C. It's just we know it exists. We have -1. 4 times -1 is? -4. Right? There is no C, or C is 0. So 2 minus 4 is? -2. So we're going to put -2 right here. That's where our vertex is. Okay? What do we know about our graphs, or quadratic graphs? They are what? What is a characteristic of quadratic graphs that we know? They're U-shaped, but what about U-shaped graphs? There's a mathematical term. Symmetric, right? So I know that the answer to here, to 0 will go to here, right? Or that the answer 1 will go up here, right? So do I want to start working my numbers from -3, or do I want to work like with an easy number like 0? 0, good. What's 0 squared? 0, good. What's 4 times 0? What happens if I put in 0? I get 0, right? So if I put 0 in, I'm going to put a 0 right here also because it's symmetrical, right? That's an easy one. What about 1? Let's put 1 in. What's 1 squared? 1, right? What's 1 times 2? 2, good. So we're going to put a 2 up here. Okay, 4 times 1 is? 4, right? What's 2 plus 4? Good, so I'm going to put a 6 down here. Where else can I put a 6? Next to the negative 3. Are you guys following me so far? Raise your hand if I'm going too fast. Okay. Now you're going to take your iPads out and start graphing this thing, okay? I'll graph it with you. That way you have an example to follow in case you get lost. Wrapping this up here, we have a solution here, x is equal to negative 2, and x is equal to 0. These are both solutions, okay? Right? Another way people wrote solutions are negative 2, 0, 0, 0. That's fine. Okay? So, long process, right? Raise your hand if you feel like this is a long process. Okay, totally. So, I want to have you spend time in class starting on your homework, okay? Because it's 9:11 right now. So you'll have about 25 minutes. No, not 25. 15 minutes left. Okay, 15 minutes left for you to work and ask me questions. If you get stuck, then come and ask me for help, okay? Because I know a lot of you are going to get stuck. So don't just sit there and say, I can't do it. If you get stuck, say, I can't do it yet, I need help, okay? You got it? All right. That's it. That concludes our lesson.